welcome to the 3 days blockchain webinar organized in collaboration with ACES, Taran, and Non-Educity, where we dive into the fascinating and revolutionary world of blockchain technology. Association of Computer Engin- Association of Computer Engineering Students is a non-profit student organization dedicated for the sole benefit of students in tech field. ACES has been conducting various training sessions, hackathons, and workshops, including web development, web designing, MER and stack, machine learning, cloud computing, cybersecurity, and many other such fields of computer engineering in collaboration with various sublime mentors across the world. And today we have Varun Choda with us. Educity, launched by Nouns Labs, aims in guiding students towards their dream careers in today's rapidly evolving tech landscape with the unique PAP model empowering students to shape their professional journey confidently and without undue financial concerns. And I am Arzu Gautam, your host for today's session. Blockchain is revolutionizing industries around the globe, and today we are here to learn and explore its applications, innovations, and implications. Over the next 3 days, we'll uncover everything from the nuts and bolts of blockchain to its real world applications. We'll have interactive discussions, insights from seasoned pros, and even a Q&A session where you can pick their brains. Now, without further ado, let's hand over our screens to our today's tutor from Edacity and get ready to leap into the world of blockchain.
Hi, good evening, everyone. Welcome to an exciting webinar on the world of blockchain today. My name is Nidhi Sajwan, and I'm the program manager at educity here. I'm super excited to see you all here. We're going to explore Ethereum, private blockchains, Polygon, and a lot more on blockchain. Plus, we also have some hands-on session, as you know, where you learn to use Solidity and web integration with smart contracts. As we all know, this webinar will be continued to 3 days including today's. So let's just understand a simple thing about blockchain first. Blockchain is a game changer. It's shaking up industries and creating new jobs every day. Today, you're going to learn some great skills that can open up amazing career opportunities for you in the blockchain industry. Let me just share my screen once to share a little small slide that we have prepared for you. All right, I hope my screen is visible to everyone. All right. So, what exactly is educity? I'll just start with that first. Educity is basically an initiative by non-slabs aimed at providing top-notch blockchain education. It offers comprehensive courses and programs designed to equip students with essential skills and knowledge in blockchain technology. This platform focuses on practical learning, real world applications, and industry insights, ensuring that students are well prepared for careers in the rapidly evolving blockchain industry. Now, a little introduction about our clients first. So, we've been working with a lot of clients at non-slabs, and we have Dolce and Gabbana as our client, Polygon, Yash Raj Films, and many more. Just to let you know, guys, this is basically non-slabs clients, and EduCity is a part of non-slabs. All right. Now, coming to your directors, we have three directors at non-slabs. One is Chinka Gupta. She takes care of the operations part of the company. Vinshu Gupta takes care of the marketing and sales part of the company, and Ritam takes care of the technical part of the company. You can definitely explore their LinkedIn pages as well to know more about them. Now, what exactly is our vision and mission at EduCity? It's very simple. Mission is to build the first class opportunity ecosystem in the blockchain space. And the objective is to train you guys, students from all over the world like you, who are willing to explore the blockchain industry, the blockchain space and Web3 space. So, to enlighten you guys with the needed necessary information, that's our motive. Now, why basically nonce educity? You would get to know about it on our further programs. Basically, on our website, you can explore the programs that we have at educity for now. And Basically, we provide trainings, hand-on sessions on solidity and contract deployments, all about blockchain, all about Web3 industry, that you can get all the information at one place. Now, my colleague Tanay here would be taking over the slides, and he would be enlightening you more about careers in blockchain, basically.
So, hi guys. I hope you all are doing great, and you might be aware of what blockchain actually is. So, it's a leading, you can say, project or technology in this world. So, I'll be guiding, or maybe you can say, explaining you all the career options and fields which are like in the booming market in today's scenario. So, let me share me my screen. Today is the day for guiding you towards the development careers in blockchain. You guys must be knowing about development careers in blockchain, but I'll be leading more over it today. I hope you all are seeing my screen.
Yes.
Yeah. So, guys, this is a basically a short PPT which I've created for you guys to understand what are the blockchain careers options in the field of development. So basically, there are two main paths if you are choosing your career in development field in blockchain: um, becoming a blockchain developer and becoming a blockchain core developer. So core developers are at the top of development field in blockchain. They are the highest earning or having the highest salaries in the field. Even if you are starting fresh, like you are a fresher and you don't have much experience in development in blockchain, no issues, no little or like if you are having nothing new, no knowledge at all about blockchain development and all, you just need a basic knowledge of blocks and some programming. Like if you don't know any language, no, nothing to worry about it. You'll just and you'll have to gradually learn more about programming and becoming a solidity developer. Now, what is solidity? Solidity is a language which is used once you are getting into the career of development in blockchain. No worries if you are not interested in coding. If coding is not your like forte, you there is no such thing that you have to be interested in coding and development. If you are like interested in blockchain, you there are many career options in blockchain apart from development and coding also, like finance, DeFi, NFTs, marketing, blockchain, crypto marketing, and there are a number of, we'll be discussing in couple upcoming days. Like tomorrow is the day for career options in finance, and the day after tomorrow will be career options for marketing. So what is the learning path, or we can say a roadmap, if you want to become a blockchain developer? So start learning a coding language. Basic, or we can say entry level thing, you have to be clear about it. You have to learn a coding language: Python, JavaScript, any whichever programming language you feel which is unrestrictive and you can just learn it and then practice DSA. You have to be strong enough with DSA, data structures and algorithms, problem solving, because blockchain is a Web3 concept and technology, and because it was introduced as Web2 and Web3 are different. In Web3, the it is decentralized basically. So we offer safety and security at most. So we have to be secure and like safe. We should have safety and secure enough so that like people are hiring you, or you are good at your problem solving skills. Then you have to progress by learning blockchain fundamentals. Now you're good with the coding and programming, one language. Then now you have to progress and learn blockchain fundamentals. What is blockchain? What is decentralized systems? Varun, which we'll be having after me, so he'll be covering today decentralized and centralized systems. You all be like learning it. It's amazing concepts. So blockchain fundamentals and solidity for development. Solidity is mainly used when we talk about blockchain development. Essential tools which are required, or we can say are used in blockchain development, are Hardhead, Foundry, and Truffle. Truffle mainly is not used much these days, but yeah, these three are the most essential and famous tools which are used. So once proficient with these tools, programming language, a coding language, and DSA, you can expand into the development with React. Finding jobs, this peculiar question, and it is really peculiar in the field of blockchain. So if you are into blockchain development, how can you find jobs? The best and the most trusted and the platform which is having the most openings is LinkedIn only. Like you can join Reddit communities, you can join Stack Exchange communities, you can join GitHub, you can showcase your skills, create your own showcase, or maybe skill portfolio there. But the LinkedIn is best, because LinkedIn, you can even search job openings for blockchain development on LinkedIn. You will find n number of openings. Even Nonsblocks is always hiring blockchain developers. So LinkedIn is the best for now. Importance of data DSA or problem solving. So as I already safety, so the main feature of Web3, or we can say decentralized systems. So this main thing is always dependent on best problem solving and secure reasons. So strong problem solving is required. Security awareness are crucial in Web3 or blockchain development. So basic coders can get job, but you can get DeFi projects. Hardly know DeFi projects so easily, because DeFi projects involve finance, and finance, as you all know, finance, where finance is involved, risk is also involved. So DeFi projects are risky without sufficient skills or maybe strong problem solving. College students, I would recommend, if you are you all are, you must be college students, and hackathons are I think must be conducting in your colleges also. So you should join, like every student should join hackathons, because many companies also come, many projects, Web3 projects, blockchain development projects, any new idea, like you are you can also get hired from hackathons also, because you are working on blockchain development and you have an idea which is not existing for now. So any company can hire you. So please join it. You will learn a lot in hackathons. Salary expectations, if we talk about blockchain careers, so as per me, I've seen, according to my studies also, salaries start around 5 to 8 lakhs if you are a freshie and you are good. I'm not saying that you are into blockchain. You should be good with DSA, you should be good with language, you should be good with solidity. Basically you are a blockchain developer, so you can start your career with 5 to 8 LPA easily, like 6 LPA median salaries. Rising after year, if you are having any experience, you have done some projects, you can go up to 21, between 15 to 21. And the ending growth rate is not fixed at all, because it all depends on your skills, and you are making any project, or maybe any idea, you are deploying something, you are making your own product or any blockchain project, you can earn immensely. Like there is no as such limit. You can earn in crores also. So what educity will offer? What is the educity's role in your career guidance in blockchain? Educity basically offers, you can say it's a like school. We are not just selling our course. You can buy, you can see our videos, you can become skillful, blah blah. No, not at all. Educity is like a school, like full-time guidance for your career. Learning basics. If you are not good at basic codings and all, any, if you're not from coding background and you want to gain experience and want to become a coder or get into blockchain development, you can join us. Learning the basics, tailored guidance. Like if you are stuck in any part of your career, you can just message us or like contact us. Problem solving, DSA, mentorship from industry professionals. So we are not having the, trainers, teachers, and all. Like you will be learning this. No, no, no. We have industry professionals. Varun, who will be taking your session today of development, is also an industry professional. He's working. He is one of our most senior, we can say, experienced blockchain developer. So you will be learning a lot from him. The session will be so much exciting. I've seen. So we have industry professionals, not just teachers. I hope you get it. Companies which usually hire or hiring are Accenture, Infosys. You must be aware of these companies. There are big names. Amazon, HCL, TCS. They're hiring a lot of blockchain developers because blockchain is booming right now and will be a lot booming at the end of 2030. So Nonce Blocks is also hiring. Like Nonce Blocks is the, as Nidhi said, main head and main company, and EduCity is the program or sister company of Nonce Blocks. So Nonce Blocks also has blockchain developer. Varin is also as a blockchain developer. So for our socials, I would like invite Arjun, which is here with us, and he'll be guiding you to the our socials.
Hey guys, it's me Arjun. Once again, thanks for joining the webinar. So these are our socials and social media accounts. You can follow our LinkedIn to get job opportunities. As Tanya explained, most of the job opportunities in the blockchain space happens in the LinkedIn. You can join our LinkedIn, follow our LinkedIn profile, and you can follow us on our Instagram and Twitter for market updates and tips for beginners. As you all are beginners in the blockchain space, we do share recent market tips and tricks to become a better blockchain developer. And we do have a dedicated YouTube channel for crypto talks. Most of the contents will be related to crypto talks only. And we do have a surprise for you for all the students who follow our social media and attend the all 3 day. Like the workshop is for the 3 day. So the students who attend all the 3 days and the students who follows our socials will be rewarded with a participation certificate. That certificate which you can share in your LinkedIn profile, and also you can add that certificate into your CVs and resumes, which will really help you in your career phase because all of you are beginners. So you can make your CVs and resumes quite attractive by our participation certificate. uh, you will only be rewarded with the certificate once you finish the 3 day workshop and once you follow our socials. We'll be sharing the socials links in the chat box in the end of the session. So don't drop off in between. We will be sharing the details in the end of the sessions. So thank you, and you will be the next section will be guided with Varun. He will be discussing more about the development side. So I will be giving the floor to Varun. Thank you.
Okay, yeah. Hello, everyone. Just give me a second. I'll share the PPT and then we can start. Okay, so I hope my screen is visible. And good evening, everyone. So, welcome to our 3 day online workshop. My name is Varun Choda, and I've been working with Nonceblocks as a full stack developer. And I'm really happy to see all of you here today. And I'll try my best to make this session fun and informative for all of you. So, let's start this exciting journey into the world of blockchain technology. So, over the 3 days, like my friends have mentioned over here, we will explore various aspects of blockchain, from understanding its basic fundamental concepts to hands on development and integration. And we have planned this workshop in such a way that we'll take small steps one by one. And by day three, you will feel confident that you can work on a small personal project of your own, and even you will feel confident enough to answer any blockchain technology related questions that someone asks you. So today on day one, we will basically focus on the introductory topics as you can see on your screen, which is decentralized versus centralized systems, some blockchain fundamentals and its use cases. So why this session is important for all of you, because this will help you get the basic understanding, the groundwork of why we use blockchain, why do we use blockchain in projects, and why there is lots of demand for this technology in the market today. So I just have one request from all of you. Let's keep this an interactive session so that it's not just me who keeps speaking while you guys fall asleep. I encourage every one of you to feel free to drop your questions in the chat, or you can also drop some facts that you would like all of us to know here. Okay, so let's start with the first slide. Web 2 versus Web 3. So, with time, you must have heard of the phrases or terms like Web 1, Web 2.0, Web 3.0. So, what exactly are these? I guess with the help of these images, you might get some idea over here. Web 1, which is also stated as a static web, this term was introduced in the early 1990s and was used till the 2000. So during this period, the internet was just primarily a read-only medium. So suppose go to the internet and all that you can do was just read some blogs, go to Wikipedia, read some market articles. That's it. Just read-only medium. So websites are basically made of from HTML pages. I hope you might be aware of HTML and CSS. So just basic skeleton was there, and it was also limitedly accessible to very few individuals. But later, like after 2000, in the early 2000, we were introduced with Web 2, which is also known as the dynamic and social web. So here we were introduced with social medias. I hope everyone might be using WhatsApp, Facebook, Snapchat. All these come under Web 2. In Web 2, users were given more power to the data. So they can create data, they can post some data, or they can post some content, and they can like images, everything. It got dynamic. So it was not just read only, it got read and write. So it captured many global audiences throughout the world. So this era democratized content creation. Yeah, you might have heard of YouTube content creators or Instagram content creators. Those jobs were introduced through Web 2. And what is Web 3? So the decentralized web we are talking about today is on the era of emerging technology. So we say decentralized web, which means that there were some limitations in Web 2, which were not solved. So Web 3 brings us the power or brings us some solutions that could solve the limitations that users were having in Web 2, which we will discuss in some time in the coming PPTs. So in Web 3, users have more control over their data and their digital signatures. So you must have heard of cryptocurrencies, smart contracts, DApps, which mean decentralized applications. So all these things and many more come under Web 3. So like if we want to distinguish what were the limitations in Web 2 and Web 3, we can say that in Web 2, the control was centralized. So what we mean by centralized is there was a single governing body that used to control all our actions. So to give an example, suppose you're using WhatsApp and you have some important document in WhatsApp, but you might have come across a situation when the servers are down and you are not able to open WhatsApp or Instagram. This is because the governing body has a single server or a centralized server which is dependent for all the users. So in such cases, we are limited to the availability. So if it is working, then we are using the service. If it is not, then yes, we are stuck. So what Web3 offers? Web3 offers decentralization. So what decentralization means, just to give you overview, it is using a blockchain technology that distributes the data to different endpoints. And whenever a particular point is down, we are not able to access the data from one point. It doesn't mean that we'll have to wait for it to restart or something. We can easily access it from the other points. So that's the power. There are many more options, many more features that Web3 that we will discuss ahead. So moving on, yeah, centralized systems. Like I already told you, a single governing authority like Facebook or Twitter. So we're totally dependent on that. It's not just Facebook and Twitter. There are many other examples. I encourage all of you to like look into this topic once this session ends, and in the next session we will totally discuss more about this from your self learning. So to give a proper definition of centralized systems, we can say it is a type of network architecture where a single central authority or a mainframe controls the entire network. All the data processing and decision making are concentrated with this central point. So example are banking systems, social media, and corporate networks. The advantages that I said are efficient management. So since it is a centralized system and they have a governing body, a small governing body, so the management among the team is efficiently handled. So other things are there is a consistent policy that can be handled. So suppose Google Office is conducting a creating a policy for all its employees, so every employee will have to follow that because they're working over there. So the policy is consistent when we are using a centralized system. Now, what are the disadvantages that we are facing in this system? Single point of failure, as I just gave you example. If a server is down, we lack the uh, entire feature of that application or the entire usefulness of this application until the issue is resolved from the company itself. We cannot do anything. And the other disadvantage is scalability issue. So suppose there is a centralized system and they want to add a new feature or they want to scale the number of users and increase the transactions in that case. But since that project is already running, they cannot just stop it for 5 to 6 days and add a new feature. That is a really big issue that they face. So sometimes you might have noticed you are receiving an email that a service will be down from this to this time and you cannot use the service, so please plan accordingly. So that is a limitation of centralized system. And security risk. So yeah, your data is kept with them. So you might have heard of the news is that there was a data breach at this office. There was lots of user information that got leaked. That is a disadvantage of centralized system. People are maintaining our addresses, our phone numbers into the server, and if it is not securely kept, it might get hands into the wrong people. So that is also a disadvantage. So to overcome this, Web3 proposes decentralized systems. So to define a decentralized system uses distributes data processing and decision making across multiple nodes. With nodes, you can understand nodes as different points where they have where they involve a different identity to hold the data. So it is not a single person who is holding all your data. The data is distributed to different people. You can take them as people, to different people who will keep a safe copy of your data that is securely stored with a hashing technology. It's not just plain text that anyone can open it and read it. It is hashed with proper algorithms. So the key characteristics that you can say in decentralized systems is like independence of the nodes, the distributed control, peer-to-peer communication. Yes, you might be thinking, what is a peer-to-peer communication? So to define it, like nodes communicate directly with each other without a centralized intermediary. So suppose there are 6 nodes and the first one wants to communicate to the fifth one. So there is no boss over there that he has to take permission from the boss. Can I talk to him? Yes, that is not here. So he first one can directly communicate with sixth one or any one of the nodes in the network. So this is a great advantage. You're given you're given power to communicate. You're given power to express, and this is one of the greatest advantage of decentralized systems. So before I move on forward, uh, I'll just ask you guys if you're comfortable with my speed and if everything that I'm saying is like understandable, or is there any issue. You can drop that in the chat and then we can continue ahead if there's nothing, no issues from your end. Okay, we have a thumbs up. Out of 65 people, we have just one thumbs up. Sorry, Hariom, I didn't understand what you have written over here. Is it? Are you saying it's disadvantage? So I think you're asking for the disadvantages of decentralized system, if I'm not wrong. Yes, everything comes with some advantages and disadvantages. So, what disadvantage in decentralized system, we can say slower decision making. Yeah, that is one of the disadvantage, because it is a distributed decision making network. So each node has the option to express their opinion, since there is no centralized body but we have a distributed body. So everyone's decision should be valid, and we have to wait for everyone to give a decision or a verdict on a particular condition. That can be a disadvantage. Other disadvantage can be the complexity. So see, we are not completely moved to web 3 right now, we are still in web 2. We are shifting towards web 3. And why we haven't shifted completely? Because there is some complexity in managing these decentralized systems. So this is the reason that every year developers come up with great ideas and great algorithms, so that blockchain can be made more secure, more faster. So this is also a disadvantage, and it's also future scope for every one of us who are into the technology, who are working as a software developer, or who are even working in the non-tech lines. They can propose ideas, they can write blogs, and developers can take help from those blogs or from those research papers and try to come up with a solution. Yeah, that was a good question. Thank you, Hariom. And okay, so let's continue ahead. So we are saying blockchain again and again. So what exactly a blockchain is? So blockchain is actually a decentralized, distributed ledger technology that records transaction across multiple computers in such a way that the registered transaction cannot be altered. Yep. So what does all these heavy words mean? So decentralized, we have already discussed that there is no central governing body. Distributed ledger technology. Okay, so to give example over here, you might have seen your bank statements whenever you go to some of your you have must have seen your passbooks. So that is a ledger. It says, it has fields like credited amount, debited amount, date, sent to, and other details. That is actually a ledger. So when you say distributed ledger, it means your blockchain has a ledger which is distributed among all the nodes, which keeps it transparent to all the ones who are on the blockchain network. Suppose someone has made a transaction. Why do you want everyone to know that? Because this will create trust. So suppose there is someone who has sold a painting through blockchain, but how do you know that it is authentic? You can only know that if that transaction was carried from the owner to the buyer. So that's how distributed ledger technology helps blockchain to be safe and transparent. And the other thing was, it is registered technology. It can register transactions so that no one can alter it. Yes. So when there is a distributed ledger, if any individual tries to tamper the ledger, wants to change the transaction. So suppose he sent 10 tokens, but he wants to say, no, no, I'll just add another zero and I'll say I sent 100 tokens to this user. How do we verify that? Since the ledger is distributed, we'll just refer to other ledgers on other nodes, and we can see, okay, this data is not consistent. We will not take this information as valid. We will just consider the the data that is consistent on other nodes. So that is how we also create a trust and security over the blockchain. Okay. So yeah, blockchain is also the backbone of cryptocurrencies. So you must have heard of Bitcoin, Ethereum, Solana. These are different blockchains, and they have their own cryptocurrencies. They have a market for this as well. Like we have share market over here, so we have cryptocurrency market also there, where users trade their currencies, earn from them, and the technology behind this cryptocurrency is blockchain. Okay, moving on. So yes, you might be thinking how exactly the blockchain works. So with this diagram, I hope every one of you will be easily able to understand it. So suppose there is a new transaction. Transaction means anything that you are sending a token or you're creating NFT, anything, that is all a transaction. So a transaction, whenever is created, it enters into the blockchain. The transaction is then transmitted to a network of peer-to-peer computers scattered across the world. As we discussed, peer-to-peer means different nodes are made, different nodes exist on the blockchain, and through these nodes, you can easily access the ledger. So this transaction is not sent to a single node; it is transmitted to all the nodes that exist on the blockchain. So this network of computers then solves a equation. So how do you know that this transaction is a legit transaction? So there are some mechanisms, some algorithms that these nodes use to verify if the transaction that is coming is a legitimate transaction. And once the transaction is legitimate, once it is confirmed, only then that transaction is added into a block. So when we add the transaction into a block, then we form a number of separate blocks, and they're all chained together, creating a long history of transactions. And this is how we name the term blockchain. And when a block is added to a chain, then the transaction is completed. This is just an overview that I'm giving you. There is a lot behind what is happening over here. So just to give a brief, it is the best example I can possibly explain. And you can see a symbol in this first image. Let's see, does anyone know what this symbol is? What cryptocurrency symbol this is? You can drop your messages on the chat. It's a very common cryptocurrency. I hope someone might know. Yes, yes. That's Bitcoin. So for this example, the diagram that you're seeing, it's for Bitcoin. The working is slightly different when it comes to other chains like Ethereum, Solana. They have the separate working. So you can refer this, but yeah, if you want to know more, you can Google it, and you can also understand about how different transactions work on different blockchain networks. So let's move ahead. Key components of a blockchain. Okay, let's do one thing. I'll just share a website link to you on the chat, and you guys can also open it on your laptops if you're on your laptops or on your mobile. And I'll just show you how a blockchain is formed with example. I'll also share this tab on this meeting as well. One second. Yeah. So I hope it is visible to everyone. Can someone just confirm with either a emoji or a message? Is it visible? Okay, yeah, that's great. So what we see first is SHA-256 hash. It is an algorithm that blockchain uses to securely hash a particular data. So you know that we cannot simply keep our data on the blockchain as a plain text. We first use a hashing technology, hashing algorithm to first hash the data and then process it accordingly to the blockchain. So you can see a hash written over here. And if I type anything over here, see, on every word that I type, it changes. That means a hash is totally unique for every data. It cannot be same for two particular datas. So that's how we maintain consistency. And if I write like hello, okay, so this is a hash that we get for this particular data. And like we get a hash. Okay, now moving on, we see a block over here on the top section. Okay, now we have more fields over here. We have a hash here, we have data, but we get two more fields. One is the block and other is nonce. So what is a block? It is a number. So one means it is the genesis block, means the starting block of a blockchain. So we say it's one. What is nonce? So nonce is exactly a problem that we have to solve. And what is the problem? See, in the previous section, you saw hash was starting with any alphabet E3B0. But here we see hash is starting with four zeros. What does that mean? So when a data is typed here, we have to verify it. We have to sign the data so that it is signed by a particular user. That means it is a data that he wants to be recorded. He will sign the data. So when I write uh, hello everyone, see it changed and the color also changed to red. So this means this is not a verified data yet. It is a data, but it is not verified. So how do we verify it? With the help of nonce. Nonce will run a logic over here that will check for every value that it can find, so that the first four digits over here we can get as zero. First four digits, when we get zero, it means yes, this is a unique data and it has been signed by a user and it is ready to get on a blockchain. So see, if we click on this button over here, mine button, it will run the logic and check for a number that will give us four zeros. See, the background is also green. We get a unique nonce over here, and the first four digits are zero, which means this data is ready to get on a blockchain. So moving on ahead, you can see a blockchain tab over there, and we have a number of blocks over here lined up together. So what if I type anything over here? Again, that we noticed behind in the blocks, it changed to red, and its hash also changed. Earlier it was 000 in the starting, now it was changed. But here is one more field, previous. So I hope you know what a linked list is. If you are not aware, I'll just say linked list is actually a data structure which stores the address of the next node and a data. It has two fields, a data and the address of next node, which it points to. Over here we have a previous and hash here. So over here we are using a doubly linked list. Doubly linked list means it will store the address of a previous node and of the next node. That's how we will form a chain of this. And previous one is all zero for the first one, because it is a genesis block. Yes, so for the first one we have all zeros, and for this data we have this hash, which will be the previous for the next block. And yes, you can verify it ahead. Moving on, see, this hash is the previous for the next one. That's how a chain is formed. What if someone on the blockchain network tries to alter a data in the center? This is no data. So see, every block ahead of this turned to red, which means there was some issue after this green block that was not handled and the entire blockchain was disrupted. Then how will this be fixed? We will have to again mine this block. We will get a new nonce, a new hash, and every block has to be mined again. See, and this also. Now we get a green blockchain network. But how do you know that the data which was added over here and mined and the entire chain ahead was a legit data? It was not someone who altered the existing data. So suppose this was the original data and someone just changed it to this and then mined the entire blockchain. So he has something in his mind and he wants to just spoil the blockchain network with a false data. How will this be captured? That's how the distributed word comes into picture. So what distributed means? We have different peers, peer A, peer B, peer C, and like this we can have any number of peers. And you can notice that the add hash that is here, like 401578, 401578, it will be same throughout the all the peers. So if any data is changed in this particular peer, like suppose peer B is the one who changes some data and wants to alter the blockchain, and he mines all of these, will he be able to merge all the data into the blockchain? No. Whenever you might have you saw the picture before. I'll just go back on the PPT. So see, on the picture it is said the network of computer then solves the equation to confirm the validity of a transaction. So all of these computers, like all of these nodes, will solve the algorithm, using the algorithm solve the complex problem and come to a conclusion that, hey, see, my last address is this 0004 E4B. his is 30E8, which one is legit? So he will consider another peer. He will say, okay, so you also have E4B. E4B. That means our data is right, and this blockchain was is this blockchain handled the data incorrectly, or someone has tried to put a fake data over there. So they will just reject this chain. This peer is not consistent. They will reject peer B, and peer C and peer A will be the ones who will agree that yes, this data can be put onto the blockchain. That's how blockchain maintains security, transparency, and consistency that we're talking since the starting. So I hope this was a good example for every one of you to visually see how the blockchain is working. So as you can see, this is just a demo blockchain. We were not actually adding anything to the blockchain. This was a like a learning platform that some developer has created for all of us to understand how the distributed blockchain works. So there are other fields also like tokens and Coinbase, but these are quite complex topics for the time being. If we get time on the day 3, I think we can discuss it. Otherwise, you can take this as a self-learning thing and explore it on YouTube, read articles. How is this thing working? How tokens work on the blockchain network? Okay, so was this clear using the diagram? Can I get some feedback over here with like any emojis or anything? Okay, yes, I feel everyone was comfortable with this. Even when I started blockchain, I also referred to this website, and it also helped me clear lots of doubts and the basic understanding with blockchain. Okay, so yeah, I guess you might be now comfortable with all the components of a blockchain, the key components that are on the PPT. A block is nothing just a package of data containing transaction records, and each block typically includes a timestamp. Yes, that this was not mentioned. I didn't mention this before, but yes, every block and every transaction has a timestamp. Timestamp means it records the date and time when this transaction took place. Just as your passbook, you have seen that on this day I sent this much money to this one or received this money. That is the timestamp. So blocks basically hold information about the transaction, the sender, receiver, amount, and the cryptographic signatures. So next is chains. So blockchain is a distributed ledger, as you know, and it grows new blocks every time in a linear direction. So linear means that the next block will come just ahead of the previous one. So it will form a line, straight line moving forward. So chains of a block is secured through cryptography. You might have heard of the term cryptography. So cryptography ensures immutability and transparency of transactions across the network. So I know these terms are big enough, but they simply mean that immutability means it cannot be changed. Transparency means it is visible to everyone. It is totally safe and totally transparent. And nothing has been changed. Or if something has changed, then everyone will know. Okay, this date, this token was again sent to this person. So that is transparency. Everyone will know everything. Nothing is hidden from anyone. And blockchain technology eliminates the need of central authority that we discussed. So, what are nodes? So, nodes you might have heard in data structure as well. Nodes are just individual computers in case of blockchain that participate in the blockchain network, and these nodes maintain a copy of the blockchain. So, as we saw on the diagram, there was a blockchain copy for every peer, peer A, peer B, and after these peers verify and validate the new transactions and blocks, only then the data is added to the real blockchain. And how are they managing this? How are they verifying this? And that is done through the next word that you see, consensus mechanism. So consensus mechanism, it might it might be visible as a very heavy term, a complex thing, but no, it is just an algorithm that each chain follows to solve that complex problem. So suppose we are saying blockchain, Ethereum, Solana. Why do we have different blockchains? Because all of these blockchains brought us different mechanism. Some are like, I'm not I'll not compare these mechanisms right now, but I'll just say that different blockchain networks are introduced because they brought different mechanisms for solving this problem. Some offered quick solution, some offered more secure solutions, and some offered a like intermediate between them, a linear solution that is taking average time but is also solving the problem accurately. So there are other use cases as well in different mechanisms that you can discuss that we can discuss later, or you can also explore them on their own. You can note if you want to note. So you might be familiar, or you might have to go through proof of work. Proof of work is one, then proof of stake, and then proof of history. There are other many mechanisms that are used in different blockchains. Okay, so yeah, so we have been discussing what is blockchain, what is centralized, decentralized, but what is this bringing? What benefits are we getting from this? So as we have already discussed, Tane has said that it is an emerging technology. Yes, it is definitely emerging technology. So many of you must be thinking cryptocurrency is not a good option in India or in other countries. That is not the case. See, you are developers, you provide solutions. How will you know if you not try it? We are not saying you to like make transactions with real money. We have projects that use fake tokens for developers to learn the technology. We say it faucet. So we are offered test tokens for developers who are working on projects, and they can try to create a transaction on the test environments on the blockchain and try some projects on their own. So why this technology is emerging? Because we are given the power to work with temporary tokens. We don't want to directly create a transaction that involves money. No, we are not doing that. We are making test transaction which involves test tokens, and we can create projects, we can increase our learning, we can learn new skills, and we can introduce new solutions to the market which are awaited right now. So that's how it is an emerging technology. uh, it has wide range of applications. So where else we can use blockchain? We can use it in finance, we can use it in supply chain, we can also use it in healthcare, and many more places. And it has lots of job opportunities right now and in future and in past. Blockchain has every time opportunities and demand in the market. So, guess we discussed transparency. You might be aware of it till now. Security, yes. So, how is it secure? So, we mentioned we are using algorithms to hash a particular data, and that hashing is only one way. So, with the hash, you cannot, like, if you are having a program or a heavy computer, that you might think someone will retrace our data. No, that is not possible. So hashing algorithm is safest thing, and it is also used in many MNCs right now to store the user data. So hashing is the securest form of storing data. So like whenever you create your account, servers are not holding your password in a plain text. Like if you entered 123456, no, it will not hold it like that. It will be hashed using an algorithm, and only after the companies will store your data so that you can do log in, or you can use social signups in other websites. So yes, the next topic is immutability. Immutability, yes, blockchain, once data is added to the blockchain, it's totally impossible for a single person to alter the data and directly publish it on the blockchain without verifying it from someone. Every node will verify the data first, and only immutable data that was positively recorded will be added. And decentralization, we have discussed it lots of time. Decentralized means it is distributed among different nodes and not given the power to a central body. There are other benefits also which are not mentioned here, like uh, blockchain is a future technology. It will bring future technologies to us, future projects to us, which we are not even aware right now. And that's the developers which bring it. The developers will create some unique solutions, unique projects, and offer us more flexibility in the Web3 scope. Okay, so yes, moving on. Use cases of blockchain technologies. Yes, cryptocurrencies are always there. You can always use cryptocurrency to create a transaction or purchase something on the blockchain network. And there are smart contracts, yes. So let's hear it from you guys. Do you know what a smart contract is? You can share your thoughts, anything, whatever you feel. How is this contract smart? You can share it on the chat if you have heard of this term before. Okay, yes, it is stored on blockchain, that's right. No one else. Okay, no issues. We are here so that you can know about these terms. I'll tell you. So smart contract is actually a program. So you write code on C++ or you write code in Python, right? So smart contract is a self-executing program. I'll tell what a self-executing program is in a time. So a smart contract is a self-executing program that is written using Solidity programming language and is used to create projects and communicate with the blockchain network. So how smart contracts are used in the blockchain sphere? See, when you write a program and it has been published to the blockchain, you cannot alter it. So it will have to work on its own whenever someone makes a function call. So once the logic is written, it will be posted on the blockchain network, and then users will call its functions. So you might be aware of what a function is. So you'll just have a function that is just directly a getter function, means you will just call it and it will return some data. Or there are parameterized functions which will ask you for some inputs, like give us a give us a user's name and we will return the user's balance. So that is a smart contract. I'll show you guys a example contract. Let me just give you an example. Okay, one second. Okay, yes. I hope my screen is visible. So see, whenever you write a smart contract, it gives every user on the internet to the ability to see what is written inside that. Gives it more safety and more transparency. So suppose you wrote a program and you asking the users to use your smart contract for interaction, and how will the user know that you have not written any like fishy code in that you might use to steal or hack the data? That's the reason why blockchain is here. You can directly see, you can read the entire smart contract. This is an example smart contract, and this is a website like etherscan. This is a explorer where you can see every details related to the transaction or any contract information of a particular blockchain. Right now we are on the Ethereum blockchain. You can see Ethereum price. This is a Ethereum explorer. So like this is a very complex smart contract. You don't have to like understand what is written over it, but I'm just giving you example how a smart contract when put on a blockchain can be easily read by anyone. And then you have some function calls. See, read contract. So these are the functions. Name, its contract name is tether USD, and the total supply means the token count. This is, so these are the functions that users can call and even use parameterized constructors. So these are parameterized functions, like you will send some value here, then you will call the contract, and then you will get some data in return. So that is an example of a smart contract. So there are many use cases of the smart contract, as I mentioned, in the healthcare technology, in Web3 space, in finance projects, in supply chain management, everywhere. So yes, what is the voting system that is written here? So right now, I guess everyone we might be knowing we give voting to a political party whenever there are elections, everything, or even to the class president, we give voting over there. So you might have seen that first we take a page, we write whom we are voting for, and then we put it into a ballot paper. But how secure is that? When it is getting counted, do you know who is legitimating counting it correctly, or if your vote was counted to the separate person? How is it safe? So you can use a blockchain technology to build a voting system where users can vote through the blockchain network. And as you are aware that every transaction on a blockchain is transparent, every user can see who has voted or uh, who has passed this vote. So through this, it is totally safe and totally legitimate that you're giving your vote, and you can also see that yes, my vote was received to the correct person. So that's how a voting system can be made secure through the help of blockchain technology. Healthcare. So yeah, why I'm saying healthcare again and again. So see, whenever you visit a hospital, they maintain a record of you, right? And you might be aware of that, you might not be aware of that, but in some cases hospitals share your personal details to like health insurance companies. Why? Because when you go to take a health insurance, they will see, okay, this person already has a medical record and he's hiding it from us, and we will charge him more premium on his health insurance. So that is not a good thing. Your personal data is being sent to anyone without your knowledge. But if a healthcare is brought on the blockchain network, all your data will be put in a block that is securely hashed using an algorithm like SHA-256, and it will be present there, and only you as the individual who has the private key. You might not be knowing right now, but we have two keys in blockchain. One is the public key and private key. So we use these keys to sign the data. So as I mentioned in the blockchain demo, you are hashing, your hash is getting created, and in the next step you are using the nonce to get a signed data. So that signed data is created when uh, you use your private key to sign the data and then send it to the network. So that's how it's you who is signing the data, and it's you who will be able to retrieve the data through your keys. So that's how your data is kept safe on the healthcare platform when it is brought under blockchain. So yes, challenges. You might remember that when I started, I said that blockchain has its decentralized system has some disadvantages, and that disadvantages can be said to as challenges. So we are right now using Web 2, and we want to migrate to Web 3. But these challenges are limiting blockchain to be fully brought into picture. Scalability. Sorry. So scalability is a challenge. How? So see, we have to distribute the data on nodes, but these nodes have to be very strong computing power. These should have strong computing power to solve these complex algorithms, to solve this data and then verify this. This requires lots of hardware resources. So scalability is a issue when you don't have a proper or powerful computer. We cannot form nodes. So this is one of the challenge. Then interoperability. This means that development of the protocol that facilitates communication and data exchange across different blockchain networks. So we have said that we have different blockchains like Bitcoin, Ethereum, but these blockchains are not linked to each other. They have a separate identity. They have different transactions recorded on them. So we have the challenge to communicate our data from one blockchain to another blockchain. We have solutions right now, but we face challenges to provide an optimal solution. And energy consumption, yes, I said that hardware utilization is very extreme. So if you Google it, you can see the uh, blockchain miners. You can search mining facility or mining warehouses. Yes. So users in the other countries have also taken it as a profession where they solve these where they solve these problems in a and set up a very big warehouse of computers with so many CPUs, so much processing power, so that they can earn a reward after solving the problems on the blockchain. So blockchain offers some tokens to the miners who solve the problem and verify it and then put it on the network. So they get some reward in exchange to that in form of cryptocurrency, like the users who are solving a program or uh, solving a challenge on Bitcoin network, they will be rewarded a Bitcoin. Like it's not one Bitcoin; it will be a fraction of Bitcoin. So they are earning, but energy consumption is way too much. If I can just pull a picture, 1 second. Yes, I got a picture. Uh, yes. So I guess you might be able to see these pictures. So these are warehouses. So these people have put so many CPUs, so many chips together so that the blockchain network problems or algorithms can be used to verify the data. So this is also profession for some of the people who can afford it, because yes, it will obviously be very costly. So this is the like this is a this profession is called mining. So people set up very big warehouses just to like earn a fraction of reward. And with time, yes, these rewards will decrease. So that is also challenge that they have to provide a optimal solution or optimal arrangement to solve solve these equations properly without utilizing many of the hardware resources. Okay. And security, yes. So we are aware that it is using hashing technologies, but even using that hashing technologies, you might be aware that there are some frauds that happen through emails or messages that click on this link and you will get this as a reward. So that is also prominent on Web3 sphere. So people try to lure you with some offers, and when you click on those links, all your hard earned crypto or your wallet money is stolen. So that is a security challenge. There are other security challenges as well, and developers are continuously working on some solutions, some programs, or some softwares that can help the transition of Web 2 to Web 3 easily. Okay, so yes, future directions. The limitations are exactly the future directions. So if you'll see, the developers are trying to find some scalability solution, interoperability protocols, privacy enhancement, governance model, so that like if uh, if governance model can be introduced, then the new users can follow them and create a safe environment for them to migrate to Web3 sphere. Sustainability initiatives, it means like shifting towards efficient energy consensus mechanism or hybrid models to like reduce environmental impacts. So yes, these are future directions for Web3, which Web3 is still looking, and developers are continuously working to provide the best solution. And yes, and we come to the conclusion for day one PPT. I hope it was not overwhelming for all of you. So on day one, you learned a lot of theory, but this was very important theory, because in the next session that we will discuss tomorrow, it will be hands-on with Solidity. And when you're working with Solidity, it's essential you might know what a centralized system is, what a decentralized system is. You should be aware of the fundamentals of blockchain. And I hope this session gave you or introduced you to almost every essential topic. And I'll encourage you all to go through this PPT. We'll share this PPT with you. Go through the topics, explore it on your own, If you get some interesting facts, you can share it with us in the next session. And this will also help you come prepared for the next session, in which we will be doing some coding with Solidity programming. And yep, that's it from my side. If you have any questions, you can bring it up in the chat and I'll try to answer those. Thank you, everyone. Anything, don't hesitate. It should not be like, I don't know about this topic, will everyone laugh at me? That's not the case. Ask anything, like, should I learn blockchain, or should I just go into the web development sphere? Okay, so we have a question. See, how are nodes decided for a network? See, everyone can become a miner or a node. Every blockchain has a program. You'll just have to provide some basic details. You have to sign up on blockchain. Like for Bitcoin, you have to sign up on a page that they offer. You register as a node, and then once that is done, once you get verified, you can start becoming the person who is in charge of a node, and you will be given a particular ID number. So suppose you get 7 or 71, so you'll have to again do every step that other peers are doing to maintain a consistent data, verify it among each other nodes, and the one who solves these equations, these complex problems, and verifies the legitimacy of data, his block is then added to the real blockchain. So that's how nodes function. You can explore it on the blockchain networks, whichever you prefer, like on Bitcoin, on Ethereum. They offer programs for this. Yes, anyone else?
Guys, you can even turn on your mics and ask any questions or doubts you have.
I feel that everyone over here got the uh, got what I said in a single session. So very very smart of you guys. If there's no issue with you, I guess you might have understood everything that I shared right now. But still, if any minor doubt is there, like you didn't understand a topic, or if you want me to explain more about that, I can totally help you with that.
Actually, sir,
Yes, yes,
I want to know more about this interoperability. Right now, you said in this slide,
yes, yes,
interoperability.
yes. I'll tell you what.
Can you please explain it again?
Okay, okay, yeah, sure. So, as I said, that there are different blockchains. Like, there, for example, I'm giving examples of Ethereum, Polygon, Solana, Bitcoin. These are not just tokens; these are separate blockchain networks. So, suppose one of you is using Polygon chain, and you want to buy something on a website, and the user is saying that I'll only accept Bitcoin over here for the transaction. But you are on Polygon and you have the token that is relevant to Polygon chain. How will you communicate between these two chains? That is the issue. So interoperability is a, like is a is a is actually what do we say, is a issue. Yes, sorry, it is a issue that users are facing these days, to migrate from one chain, or to send data from one chain to another chain. So this interoperability is looked as a future solution that we we developers will bring, so that the communication between these chains becomes easy. So you don't have to just uh, um, go to the separate blockchain. Like if you have to purchase some Bitcoin related asset, then you will have to create a Bitcoin wallet. No, that's not the case. You can directly do that from a Polygon chain. So that is what interoperability is, I hope Arju I was able to explain it. Was it clear this time?
Yes, yes, thank you so much.
Most welcome. Okay, so security. Yes, security, as I mentioned, we are using some hashing algorithms, right? I mentioned SHA-256. We are not limited to that. We have KCUG, we have other hashing algorithms that are used in different blockchains. So security is maintained through hashing algorithms. We hash the user data. I was just writing hi, hello, but that is not the real data. Real data can be your entire transaction that was created when you purchase something, or uh, when you interacted with the blockchain. There is a transaction. So your data will be a lot of fields. It will have your name, your timestamp, your like the website name, anything. It can be anything. So that data is first hashed so that it can be securely transmitted over the blockchain network. And the next thing that you're saying, uh, it is, sorry, integrity. Okay, so to first define integrity, you should know the definition. The integrity is the quality of being honest or having strong moral principles. So what does that mean? So see, we are having different peers. How do we know that the integrity is maintained? So the state of being undivided or unaltered, that is maintained through different peers. You are not just pushing the data directly to the legit blockchain. You are first confirming it with the peers, that yes, please confirm that the latest block that you have has the current hash address. It means that the data whatever is in that block matches to the hash which I am having. If the hash matches, yes, we both have the same block. And yes, we will again verify it with a third node, with a fourth node. And yes, once every decentralized node confirms it, yes, you are right, this is the this is what majority nodes say. Okay, now we can finally add it to the blockchain. That's how integrity is maintained in the blockchain. I hope, Navneet, I was able to answer your doubt. Yes. Okay. Awesome. Okay, so the next question we have is, how is concurrency issue handled? Are the requests sent to a particular node or anyone available? So see, whenever a transaction is recorded, every node receives that transaction data, but that will be in a form of hash. So that's what every node is trying to do. They are trying to solve this hash through the algorithms, through the proper techniques, and they want to verify that transaction. And once it is done, they wait for every other node. It is not uh, it is not the case that you have to wait for everyone. We wait for the majority votes. So those over who have solved it, we will wait for 2 3, or anyone who is available at that time, any number of them. And the majority which is there, it then gets added to the block. Latency, yes, as I mentioned, there are some some disadvantages or drawbacks in Web3, which developers are continuously working. So they are working with some consensus mechanism that doesn't have to wait for every other person to solve it. Like, to give an example, we have a proof of history, or no, we can take example of proof of stake. Yes, so proof of stake, just to give an overview, in this mechanism, whoever the miner is, whoever is solving the problem, he will have to put some of his currencies or some of his tokens in the blockchain as a safety measure, so that whenever he is publishing a result, and before it is verified, there is a like, we have his money or we have his asset in our hand, and if the data is right that he has shared, only then he will be rewarded and the data will be published on the real blockchain. But suppose the solution that he provided was incorrect. In that case, the proof of stake, what it does is whatever he has staked in the blockchain as a proof of his work, it will be deducted because he did wrong calculations. So he will not receive his whole amount that he put on as a safety measure. He will get some amount which is debited from his whole principal amount. So that is the like punishment that he will get. So this is also an algorithm. So it doesn't have to wait for everyone. If we found that his data is inconsistent in like two to three nodes, then he will face the issue. So that's how to reduce latency or other possible issues in blockchain. We are we or the developers. I mean, we means developers that like try to come up with an optimal solution are working hard to give the best solution or best algorithm so that uh, less security issues come and less hardware utilization is there. Yes, good questions are coming up. So, like, is there anyone who was already familiar with all these topics? Not all these topics, like some of these topics. If you were like, you can mention which all topics you were already aware of. Like, someone was already knowing about a smart contract is, or is someone already knowing about centralized and decentralized things? They have heard it from not in blockchain perspective. They have heard it from another sources in another domain. Oh, that's great. I hope then I was able to bring up some interesting facts or interesting topics in this webinar, and I hope that you will definitely explore more about this, and you might like, get some interest in this domain as well. Okay, yes. So our team is sharing our social handles, and we encourage all of you to just visit him, like to explore our social handles and follow us. And I guess our team will be able to like explain more about this topic. So I'll just hand over to Nidhi.
All right, guys, I hope all your questions were cleared. We'll have another session tomorrow. Just to let you know, tomorrow's development session would be hands-on with Solidity and contract deployment, and there'll be a very short consulting sort of a session on careers and blockchain related to finance field that Tanay and Varun would be taking over. So yeah, we'll just end our session. It's almost 9:30 now. And if you have any feedbacks for us, we'll have a feedback form at the end of the session, like at day 3. But if you have any question, you can drop in the group, and maybe we can coordinate with your admins. So yeah, thank you so much, guys. Have a great day. Bye bye.
Okay, thank you everyone.
Thank you, guys. Thank you, everyone. Bye bye. Have a good night. Thank you, Anurag.
Thank you so much. Thank you so much.
Thank you. Also, guys, if you have any doubt regarding anything, you can just contact us or ping us at our LinkedIn. We will solve all your doubts regarding your career, maybe any topic or anything like that. This is our LinkedIn. I've already mentioned. You can follow us on LinkedIn and Instagram, and you can just DM us. Any queries are always respected.
Thank you so much for your research session. We'll explore more further tomorrow.
Yeah, okay. Okay, Arjun. Thank you so much for joining.